Number 18 here in 4.5 is a goofy little problem. It's a limit as x approaches 4 of the difference of two fractions. Now, we've said a lot here that to use L'Hopital's rule, you've got to get one of those indeterminate forms, most commonly 0 over 0 or infinity over infinity. This probably isn't going to give us that because it's two different fractions being subtracted. So what are we going to try to do? We're going to try to combine these two into one big fraction here. So what I'm going to do here, guys, is move this part over here just a little bit. And I'm wondering if you guys noticed this. This is something we dealt with back at the very beginning of the year here in Chapter 1. These two denominators are related. X minus 4, I want you to notice, and the square root of x minus 2. The square root of x is the square root of this term right here, and 2 is the square root of this term right here. This is almost like what I call force factoring a difference of squares. We're going to multiply this first fraction now by the square root of x plus 2 on both the top and the bottom. And I think that's going to give us the common denominator that we're looking for. So this is the limit as x approaches 4 of, all right, let's see what happens. This numerator times this numerator is just the square root of x plus 2. And down here, we would do FOIL on these two binomials. Root x times root x is just x. And what I'm hoping you guys see here, the outer product and the inner product are opposites of one another. They cancel each other out. So my last product now, negative 2 times positive 2, is a minus 4. And then, ooh, there was a minus sign here. I forgot to copy. So then minus of 4, ooh, I just realized I wrote that numerator incorrectly. That square root should have stopped just over the x. So, okay, there was a plus 2 at the end of that, and then there's a minus 4 over x minus 4 at the end. And now that we've got our common denominator, now we could rewrite this as the limit as x approaches 4 of one fraction. X plus 2 minus 4, square root of x, is the square root of x minus 2 all over x minus 4. And after all that work, guys, now we can try to do direct substitution, plug and chug, and find out if the limit works or if L'Hopital's rule applies. So if we plug a 4 in there, the square root of 4 is 2, minus 2 is 0. That's a good start. And down on the bottom, 4 minus 4 is 0 as well. 0 over 0 is the indeterminate form we most often get. So yeah, we can do L'Hopital's rule now. So all of that was just prep work. Now let's get to it. That limit is equal to the limit as x approaches 4 of, and here we go, guys. We take the derivative of the top and the derivative of the bottom. So the derivative of the square root of x is 1 over 2 root x. Hopefully you have that one memorized now. And then minus, well, the derivative of 2 is 0. Down on the bottom, the derivative of x is just 1. The derivative of that 4 is 0 as well. And so that's it here, guys. And I'm hoping plug and chug is going to work now. If we let x equal 4, the square root of 4 is 2, times that 2 right there is 4, we're going to end up with 1/4 for our answer here for problem number 18.